Logarithm of positive numbers less than 1. Positive numbers less than 1 are decimal numbers. For example, we can take 0.023. We want to get the logarithm of this number. For us to be able to do that, we express 0.023 in standard form. So we say 0.023 is the same as 2.3. We move the decimal point 2 places to the right, and then we multiply by 10 to minus 2 because we have moved the decimal to the right. Now, using the logarithm tables, we can get the logarithm this 2.3. That is, we express 2.3 to the powers of 10, and using the tables, logarithm tables, we get it is 0.3617. Then we multiply by 10 to power minus 2. Now here we can say for us to get the logarithm, so we need to add minus 2 plus 0.3617. So this is a negative number, that is minus 2, and this is a positive number. So under normal circumstances, then we would say this plus this and we work out. But in logarithm, we don't do it like that. We write this is equals to 2 bar point 3617. What this means is that this is a negative and this is a positive value. So we are mixing a positive value and a negative value. This is positive. So when you combine both, that is the logarithm. It is read as bar 2.3617. Let me write that for you. So it is read as bar 2.3617. The negative sign is written above 2 to emphasize that only the characteristic is negative. So we are going to do a few examples to see whether we have understood what we are talking about. In this example, we will find the logarithm of 0.68, part B 0.021, and part C 0.00029. So we start with A. What we need here is to express 0.68 to the powers of 10. So let's say 0.68 is equals to 10 to power x. So once we get x, we should be able to get the logarithm. So we write this in standard form. So 0.68 is equals to 6.8. Move the decimal point to the right one step. Multiply by now 10 to power minus 1. So using now the logarithm tables, this 6.8 is the same as 10 to power 0.8 325 multiply by 10 to power minus 1. So we add, we get, this is 10 to power, when you add, you get bar 1.8325. Remember what we have talked of the bar, that it is, the bar means only the characteristic is negative, the mantissa is positive. So now this is 0.68 to the powers of 10, implying the logarithm of 0.68 to base 10 is equals to bar 1.828, not 2 but rather 3, 8325. So that is the logarithm of that number. We go to part B. We are required to find the logarithm of 0.021, and this we follow the same steps. So we write 0.021 in standard form, which is 2.1 multiplied by 10 to power, now it is bar 2 or minus 2. So we using the logarithm tables, 2.1 is the same as 10 to power 0.3222 multiplied by 10 minus 2. So when you add these two, you get it is 10 bar 2.3222. So the logarithm of 0.021 is equals to bar 2.3222. So that is the logarithm. Finally, we go to C. Our C will get 0.009. So we express 0.00029 in standard form. So this is 0.00029 is equals to 2.9 multiplied by, the decimal will move four steps, so it is 10 to power minus 4. So this is equals to, from the tables, 2.9 is the same as 10 to power 0.46, 0.4624. You multiply by 10 to power minus 4. Then when you combine, you get this is 10 bar 4.4624. So the logarithm of, let's write it down here, the logarithm of 0.00029 is equals to bar 4.4624. So that is example, and I hope you have understood how now to get the logarithm of positive numbers less than 1. Now we look at anti-logarithm. Anti-logarithm is the reverse of getting the logarithm. So, for example, what is the number whose logarithm is 0.1752? So this is to mean that you are given the logarithm so that you find the number. So actually, we can say if our number is x, it is equals to 10 to power 0.1752. So we need to find the value of x. Now, after the logarithm table, in the mathematical table, we have another table known as anti-logarithm table, and that is the one that you use. The reading of the anti-logarithm table is similar to the way we learned how to read the logarithm table, so I will not repeat that. What I will do is from the logarithm table, go to the column labeled x and find the number that corresponds with 0.175. You find this number is 1.496. But remember, we want to get the anti-logarithm of 0.752. So we have a difference of 2. So this 2, we said we call it a difference. We will read it from the table of difference. To the difference of 2, you get it is 0.001. That is a table of difference. Then you are supposed to add the 2. So you get 7, you get 9, you get 4, you get 1. This means that the number with x is equals to 1.497. In this example, find the number whose logarithm is 2.2040, part B, by 3.3452. So we start with the part A. So what this means is that if we assume our number is x, it should be equals to 2.2040. Since we are saying that anti-logarithm is a reverse of getting the logarithm, we can separate this number such that we have 10 to power 2 multiplied by 10 to power 0.24. Let's write that properly. 0.2040. So we know that 10 squared is the same as 100. So that's 100 multiplied by, here we have anti-logarithm of 0.2040. We get it is 1.60, just like the way we have obtained the anti-logarithm. So when you multiply 100 by 1.60, you get that it is equivalent to 160. So 160, so our x is equals to 160. It is a number whose logarithm is 2.2040. So that's a correct value. You can confirm by getting the logarithm of 160. We go to part B of our question, by 3.3452. So what this means is that if our number is y, then y is equals to 10 to power by 3.3452. So this is equivalent. We can separate this and write this is 10 by 3 multiplied by 10 by 0.3452. So 10 to by 3 is equivalent to 1 over 1,000. Multiplied by the anti-logarithm of 0.3452 is actually 2.214, and therefore when you divide 2.214 by 1,000, you get it is 0.00214. So that is the number whose logarithm is given as this one. So our y is that. So that is how you work out such kind of a question. So sometimes we ask ourselves, where are we going to apply the knowledge that we sometimes go through? So it is important to understand that in everything that you do, there is application. Logarithms can be applied, but for now we look at application of logarithm in multiplication and division. So let's start with multiplication. So we use logarithm to multiply two numbers. So we have 126. We have 126 multiplied by 60. We can write this as 126 in terms of powers of 10 by using the logarithm. So we say it is 10 to power 2.1004. You multiply by 10 to power 1.7782. So this we have used the logarithm table to be able to express 126 and 60 to the powers of 10. Now using the first row of indices, we can add because we have a common base. So when you add 2.1004 and 1.7782, you get 3.8786. Now we can again separate this and write this is 10 cubed multiplied by 10 to power 0.8786. So we get the anti-logarithm of this, and we will get that 10 cubed is the same as 1000 multiplied by the anti-logarithm of 0.8786 is 7.561561. So when you multiply by 1000, you get this is 7,561. So that is the product of 126 multiplied by 60. So we have applied the logarithm to multiply these two numbers. So division is another area where we apply the knowledge of logarithms. So we use logarithms to divide. For example, 9/6 divide by 12. Just like we have done with the multiplication, we write 9/6 powers of 10. So this will give us 10 to power 2.9713 divide by 12 to the powers of 10. We get 10 raised to power 1.0792. We can apply the second row of indices since it is division. So we subtract 10 with 2.9713. We subtract 1.0792. So when you subtract that, you get it is 10 raised to power 1.8921. We now get the anti-logarithm. We can separate this and say this is 10 to power 1 multiplied by 10 to power 0.8921. So this is 10 multiplied by the anti-logarithm of 0.8921 is 7.8. So when you multiply by 10, you get it is 78. You can try in using another method and find out whether when you divide 9/6 by 12, you get 78. Now we have talked of applications of logarithm, multiplication and division, but we can organize our work better than the way we have presented. So let's do these two questions again. For division, we arrange our work like this. We make a table whereby we have a column there and a column there and the last one. So this one, we write the number there. This SF stands for standard form, and this is the logarithm of the number. So for example, we have 126. When you write 126 in standard form, it is 1.26 multiplied by 10 squared. We can now be able to write this number in terms of logarithm in a better way, because we take 2, which represent 10 to power 2 when you add, and then we get the logarithm of 1.26, which gives us 1004. Then we go to 60. The standard form is 6.0 multiplied by 10 to power 1. So for 10, logarithm of 10 to power 1 is 1 point. The logarithm of 6 is 0.7. We have 782. And since it is a multiplication, we add the logarithm. So we put a line there. So when you add 4 plus 2 is 6, 0 plus 8 is 8, 0 plus 7 is 7, then 1 plus 7 is 8. We put a point there. 2 plus 1 is 3. So in standard form, then we go the reverse. 3 here represent 10 to power 3. Then we get the anti-logarithm of 0.8786, which will give us 7.561. So we can now multiply, and our final answer, now we write it here, it is 7561. That is 7,561. So the answer is 7,561. Now we come to division. So 936 divided by 12, we draw the similar table to the one that we have done with the division. So we have the number there. Our number is 936 and 12. Then we have standard form. So we have 936 is the same as 9.36 multiplied by 10 to power 2. Then we have 1.2 multiplied by 10 to power 1. So we now have the logarithm. So here we have the column for logarithm. Logarithm of 10 to power 2 is 2. Logarithm of 936 is 0.97. So we have 7, 1, 3. Logarithm of 10 to power 1 is 1. Logarithm of 1.2 is 0.0792. So we put a line there. We subtract because it is division. So when you subtract, you get 3 minus 2 is 1. This will have 11. 11 minus 9 is 2. Here we are left with 6. We borrow 1. 16 minus 7 is 9. So here we have 8 minus 0 is 8. 2 minus 1 is 1. Now in standard form, this 1 means it is 10 to power 1 multiplied by the anti-logarithm of 0.8921 is actually 7.80. Now our number is, you multiply 7.80 times 10, you get 78, just like we had obtained using the other method. So our answer is 78. So we take another example. 215 multiplied by 428 divided by 214. So we are going to make our table. So this is the number column. So our number are 215, 428. But note these two numbers we are multiplying, then we divide the product by 214. So you put a line there. So the standard form is 2.15 multiplied by 10 to power 2. This is 4.28 multiplied by 10 to power 2. So this is a standard form. Then we have the logarithm column. The logarithm of 10 to power 2 is 2. We check the logarithm of 2.15. We will get it is 3324. Then we have the logarithm of 10 to the power 2 is 2 point. The logarithm of 4.28, we get 6314. And because we are multiplying here, we add the logarithm. So 4 plus 4 is 8. 2 plus 1 is 3. 3 plus 3 is 6. 3 plus 6 is 9. Point. 2 plus 2 is 4. Now we are supposed to divide the product of this by 214, so we put 214 there. When you write it in standard form, it is 2.14 multiplied by 10 power 2. The logarithm of 10 to power 2 is 2 point. A logarithm of 2.14, we get it is 3304. Then here, because we are dividing, we subtract the logarithm. So 8 minus 4 is 4. 3 minus 0 is 3. 6 minus 3 is 3. 9 minus 3 is 6. Point. 4 minus 2 is 2. Now 2 represent 10 to power 2, and then we get the anti-logarithm of 0.6334, which we get it is 4.299. So when you multiply this, you get this is 429. So this is equals to 429 as the answer for that problem. Now in this example, we are told to evaluate 2.15 squared. Now we have been using the column of standard form. Once you get used to working these kind of problems, you cannot omit it. So let's find what is 2.15 squared. So using a table, we are going now to have only two columns. So we have the number and we have the logarithm column. So our number is 2.15 squared. Now the logarithm of 2.15 is 0.3324, and it is squared. So it's like we are supposed to say 0.3324, and then this is 10, then multiply by 10, 0.3324. So instead of that, we simply multiply this by 2. So we get the logarithm is 2 times 4 is 8. 2 times 2 is 4. 3 times 2 is 6. 3 times 2 is 6. And then 0 times 2 is 0. So our number is our logarithm is 0.6648. We get the anti-logarithm of this, and from the tables we get it is 4.622. So the answer to this, that is 2.15 squared, is 4.622. So another example, evaluate 4.21 cubed. So just draw a table where we have two columns. This is a column of the number, our number is 4.2. This is 0.21 cubed. So we get the logarithm of 4.21, which is 0.6243. Now because it is cubed, we just multiply by 3. So when you multiply by 3, you get 3 times 3 is 9. 4 times 3 is 12. So carry 1. 2 times 3 is 6. So we have 7. 6 times 3 is 18. So we have 8 and we carry 1. So 1.8. The anti-logarithm of this one, 1 represents 10 to power 1. We get the anti-logarithm of 0.8729, which gives us 7.4628. 4628. So the answer to this one is 74.628. That's how you work out that. So another example, evaluate. So just like we have done with the other examples, let's draw a table. So we have, this is for the number, this is for the logarithm. We have 525.3. Then we multiply by 0.0243. Now the logarithm of this, first of all, we have 2 because we move the decimal 2 places to the left point. The logarithm of 5.253 is we have 7.204. Then this one, you move the decimal point to the right, so you have bar 2. Then the logarithm of 2.43, you get 38. We get 5.6. So we put a line there. So we first of all add. So because of this multiplication, when you add, you get 4 plus 6 is 0. So we have 0 there. Then we have 5 plus 0 plus 5 is 5. We have 2 plus 8 is 0. Then carry 1. So 8 plus 3 is 1. So here we have 3. 3 plus bar 2, you get 1. It's like 3 minus 2. Higher. We have another number here, 115. Now 115, you get its logarithm. First of all, we have 2 because of the decimal point moving to the right, to the left. The logarithm of 1.15 is 2 point. That is not point, but 2. That is 0. It is 060607. So we put a line there. So because we are dividing, then we are supposed to subtract. So 0 minus 7, you get 3. We have borrowed 1 here. So this is 4. So this is 0. We borrow 1 here. 10. 10 minus 6 is 4. Then 0 minus 0 is 0. Point. This is 1 minus 2. So we have a minus. So it is bar 1. If it is bar 1, it means it is 10 to power minus 1. Then we get the anti-logarithm of 0.0443, which we get it is 1.1099. So this means you divide this number by 10 because of this minus. So the solution to that is 0.11099. That is the answer. So this is a simple one. We are supposed to add bar 1.24 plus bar 2.32. So we say that when we have the mantissa is a bar, it means this is negative and this is positive. So you just need to separate this and say bar 1.24 is the same as bar 1 plus 0.24. Then we have bar 2.32 is equals to bar 2 plus 0.32. So we have we now add, so this will be 6, 5, and then we have 0.0. So bar 1 plus bar 2, you get bar 3. So this is equals to bar 3.56. So that's how you work out that.
So get answers for the given exercise from Teacher Wamta YouTube channel. It is important you open a Gmail email account, like and subscribe Teacher Wamta channel so that you get all the lessons and revision questions that I have prepared. If you don't know how to open a Gmail account, you can get assistance from Cyber. Or if you know how to browse the internet, you can just go to www.google.com. Then you find an option of opening an email account. If you don't have one, you can use one. If you are a student, use your parents' account. You will be able to access these materials.